Hello and welcome to Module 2, Video C, where we'll be going over histograms. For those of you joining, we're working with a data set of weather data. You can see here we have a date, humidity, wind speed, all of these different variables. And today we'll be looking at making histograms in Matplotlib. So scrolling here to the bottom, we're going to be using our same basic recipe for a graph. So the first thing we want to do is initiate our graphic. So in this case, we're using PLT, which is our abbreviation for matplotlib.pyplot, and .hist. Then all we need to give it to get this going is a list or column of data. So in this case, we're going to go to our data frame, and I want to look at the distribution of the wind speed column. So just like that, that's initiating our graphic. We won't worry about adding any titles just yet. And then down here, plt.show will print out our graph. So there we go, our super basic histogram. Of course, we actually do want to add in some labels and titles. So I'm just going to copy this in. You can see we've used plt.ylabel, xlabel, and title. And now it has some titles. This is the distribution of wind speed. Now, if you've been along for the ride since Module 1, you'll remember that when we were cleaning our data, we went through and created this column called wind type. Over here in the summary, we have some text which tells us what the weather was like, mostly cloudy, overcast, etc. And some of these descriptions included wind information. The three words that were used were windy, breezy, or some of them, as you see here, had no wind information in the summary. Something that I've been wondering is what exactly windy and breezy mean. So over here in our wind type column, we've broken things out so that if wind was not mentioned in summary, it says still, and otherwise it says breezy or windy. So now what we're going to do is I want to create histograms of the wind speed for these three different groups. So coming back down here, the first step in this is to create our different groups. So right in here, I'm segmenting my data frames based on the value of wind type, and I've created three new data frames: windy, breezy, and still. So to go ahead and make our histograms, I'm going to just copy in this code right here. Of course, I need to change my data frame, so I'm going to be using the windy data frame. I'll change this to distribution of windy wind speeds. And I'll do a similar thing for still and breezy. I'm actually just going to copy in this code right here. And we'll go ahead and print out our histograms. So here we have it. So wind speed broken into these three groups, we can see that for the still winds, we had wind speeds from 0 to about 35. For breezy, okay, we did have a bit higher, a little less than 30 to around 40. And then it looks like for windy, we had to be over 40 kilometers per hour. So that's interesting. I was curious to see if there were actually definitive definitions for windy and breezy, or if it was just someone's, observations. But it looks like they did actually base these on the wind speed. Now, it's possible to compare these graphs up and down. Something you might want to do with histograms, or really any type of graph, is to display them side by side. And so that's what we want to do next. Now, there's a few different functions that you could use to do this. but the one that we want to use today is subplot. So how this is going to work is subplot takes in 3 different arguments. So plt.subplot. Right here, we're going to do this before we even initiate our graph. And the first thing we're going to feed in is how many rows we want. So I want all 3 of my histograms to be displayed in 1 row, but there's 3 of them. So I'll need 3 columns. And then the last argument just tells which plot number. So this one is going to be plot number 1. It's the first one I want to appear. So I have that, and then just like normal, I go ahead and I initiate my graph. I add my labels, and then the one thing I'm going to change is I'm not going to show the graph. So I'm actually going to take, and I'm not going to do my show until the very bottom here. I'm just going to copy this so it's similar for each of these. So above this one, this is going to be plot number 2. Again, I do not want to show it yet. And above this one, we're gonna go ahead and say plot number 3. But again, we don't want to show it yet. So just this, if we go ahead and print them out, ooh, we have 3 graphs side by side. However, they're kind of over plotting each other. What we're going to do to fix that is we're just going to add in this command that's called plt.tight layout. And that's just going to kind of fix our layout options. Just like that. A lot better. We can see our titles, though, are still way too long. So I'm actually just going to shorten up these titles. Just windy, breezy, and still. Okay. This is looking a lot better. However, I still don't like that if I just glance at it visually, I don't see that these distributions are over different ranges. I want that to be a lot more clear. So what I'm actually going to do to fix that is I'm going to go in and specify my x-axis. So first of all, let's set some limits. So plt.xlim, we remember that this can take in a list. Actually, just kidding, not a list. It just takes in 2 values. So it looks like overall we range from 0 to maybe that's 60 there. Let's try that. So set my xlim from 0 to 60. And then I'm just going to copy this into each of my plots. There we go. Very nice. Okay. Now all our data is from 0 to 60, and we can see how the histograms kind of line up one after another after another. However, I would like slightly closer axis ticks. So I'm just going to put this in, and this here will specify my axis ticks so that they will be every 10. Using that range function. And I've told it to go up to 70 instead of 60 just because, you know, range never actually goes all the way to the top. I could also just use 61, but I put in 70. And there we go. This is really nice. The one last thing that I'd like to change on this histogram is actually the number of bins, or the bin width. So we can see here that these bins are a lot wider than these bins, and I don't really like that. So there's a couple ways that we can do this. One is that I can manually change the number of bins. So here in my line of code that kind of initiates the plot, I can say bins, and I can just give it an integer. So maybe I want to say, let's just give this one 5. Okay, that's looking a little better. I can go and give this one 5 as well. that's better. What I'd really like though is I'd love for these bins to all be of the same width. Unfortunately, there's not a way to directly set the bin width. However, we can give the breaks that we want for the bins. So I'm going to go up and do this, and I'll use the range function. And so I'm going to say that I want my bins to range from 0 to 60, and I want them to be broken up every 5. So what this is doing is it's actually, it's creating a list. So I could also put in a list here. I could have had a list that had the values 0, 5, 10, etc. And it would break the bins on that. The range function is just a quicker way to do this. However, if you wanted to have uneven bins, you could go and fully specify that using a list. But for now, I'm just going to copy that in there. And there we go. This is really nice. This lets us look at how that wind speed distribution changes with each of the wind types. This is where we'll be ending our discussion on histograms and actually on plots in general. We've gone over line plots, scatter plots, and histograms. Of course, there are many, many more chart types that you can make using Matplotlib. However, if you've kind of learned this basic recipe of, here's a good example, we initiate our graph, we add the elements, we show our graph. This is really going to help you with any type of chart that you want to make. So good luck chart making, and thanks for watching.